my friends and academic. Good morning, everyone. My name is Fasya Salim, and I'm from class 10 too. Today, I'm going to teach you guys the basic trigonometry, sin, cos, tan in a right angle triangle. And I can assure you guys, it's not that hard. So based on learner.com, trigonometry is a branch of mathematics that deals with the study of triangles. In trigonometry, we will study the relationships between the sides and the angles of the triangles, which there are three trigonometry ratio: sin, which we can say it as sine, cos as cosine, and tan is tangent. So before I get to saying the formula for sin, cos, and tan, I'm going to teach you guys how to identify the sides of the triangle. So first, in this situation, we have the hypotenuse, which is the longest side of the triangle. To know the hypotenuse, it is always the length that is opposite to the right angle here. So this one is what we call the hypotenuse. Then the length that is opposite to the angle here is what we call opposite. Then the length we have left will be the adjacent. But now, what if the angle is not here? What if the angle is over here at the top? Well then, we're gonna identify it again. The length that is opposite to the right angle will be called the hypotenuse. And then the length that is opposite to the angle here will be the opposite side. Then this one will be the adjacent. So you can see the difference between these two triangles. In here, the adjacent instead will be the opposite. Then the opposite will be the adjacent. However, the hypotenuse stays the same. It is because the right angle is still in the same position, but the angle here and here is different, which is why it affects the opposite and the adjacent. That's why I'm teaching all of you how to identify the sides of the triangle so you won't get it mixed up. So now, let's move on to the hypotenuse formula first. Again, we identify the sides of the triangle. Here, we have the hypotenuse. This one is the opposite, and this one is the adjacent. Now, we're going to assume opposite as A, adjacent as B, and the hypotenuse as C. Then the formula will be C squared equals to A squared plus B squared. So to find the hypotenuse side is equals to the square root of A squared plus B squared. So I guess you can say that hypotenuse square equals to the opposite square plus the adjacent square. This formula can be used to find not only the hypotenuse actually, but all the other sides of the right angle triangle if you were given the two other sides. And be reminded that this only is allowed to be used if it's a right angle triangle. Other than that, you are not allowed to use this formula because I'm afraid it will be a different value. So then, we're going to get to the trigonometry formula, learning about the ratios between the lengths and the angles in sin, cos, and tan. So first, I'm going to identify the lengths. Here we have the hypotenuse, this one is the opposite, and this one is the adjacent. And this one here will be called theta, or angle. So then, there's an easy way to remember the ratios of sin, cos, and tan by using this trick, memorizing so, ka, to, wa. There are easier ways to memorize this if you search in Google, but I prefer to use this way. So, how are you gonna use this to remember the ratios? We can look at SO first. The S here represents sin. Theta, or the angle that is given in the question, equals to the O, which is opposite, over hypotenuse. Because why? Each letter in front of it, S, O, and H, represents SO. So for ka, I guess you guys can assume cos theta equals to adjacent over hypotenuse. Then for toa is tangent theta equals to opposite over adjacent. So this is how you're going to remember the ratio for SOHCAHTOA, but there are of course other ways to memorize it if you search in Google. So next, let's go to some practice questions. The first question here is that you were told to find the length, which is x here. So the first thing you're going to do is you're going to identify the lengths of the triangle. Here you have the hypotenuse opposite to this right angle, then the opposite length here, which is opposite to this angle here, then this will be the adjacent. Now, you think between sin, cos, and tan, which one out of these three will need you to use the adjacent, which you're gonna find, and you were given the hypotenuse, which means you have to use cos. Cos 32 degrees equals to the adjacent, which is x, divided by the hypotenuse, 24. You move divide 24 to the other side, will be x equals to 24 times cos 32 degrees. And if you input this into your calculator, you'll get the answer is B, which is 20.35. Like that. Now, what if the situation needs you to find the angle, like here, which is x degrees? For sin, cos, and tan, there's a term for finding the angles, which is we're gonna add arc in front of them. So arc sine will be sin to the power of minus 1. Arc cosine will be cos to the power of minus 1. Arc tangent will be tan to the power of minus 1. It's like that. So now we're going to identify the lengths of the triangle again. Here is the hypotenuse, this one is the opposite, and the leftover will be the adjacent. Now, you think out of sin, cos, and tan, which one you're going to need to use the opposite, and which one you're going to need to use the adjacent? Which will be tan. You're going to assume first the angle will be x degrees equals to opposite, 12, divided by 15. Now, to move tan to the other side, this is where you're going to use arc tangent, which is x degrees equals to 10 to the power of minus 1 in bracket 12 over 15. If you input this into your calculator, you're going to get the answer is C, which is 38.66. Now, let's go to a bit of a more complex question, which consists of you needing to find the lengths and also finding the angle. So we're going to say this is D. Now, of course, in this shape, you're going to find two right angle triangles. One of them, which is triangle ABC. You were given the hypotenuse, which is 24 meters, but you need to find the angle, which is ABC. Then, you see the other triangle, which is a bit smaller. It will be triangle DBC. In here, you were given 10 meters, and the angle DBC will be 28 degrees. So, now, in these two triangles, you will have to find the length which is the same, which obviously AB will not be the same as DB. Then, the length DC will not be the same as the length AC. But we can see that the base BC is the same in these two triangles, which is why we're first going to find the angle BC. We're first going to find the length of BC. How we're going to do that is we're going to look in this triangle here first, in triangle DBC. Let's identify the triangles again. This one is the hypotenuse, this one is the opposite, and this one is the adjacent. Since we're going to need to find BC here, we're going to need to use tan. Tan 28 degrees equals to the opposite, 10 divided by BC. You switch tan 28 at BC, you get BC equals to 10 divided by tan 28 degrees. You input this into your calculator, you get the answer is 18.81 for BC only. We're going to round it off to 4 significant figures so that it will be more accurate for the final result. Then, you get to input BC equals to 18.81 meters here. Now, again, identify the lengths of the triangle. You were given this as hypotenuse, this one is opposite, and this one is adjacent. Now, you think which one use hypotenuse and adjacent is cos. Cos angle ABC equals to the adjacent 18.81 divided by 24. So then angle ABC equals to arc cos in the bracket 18.81 divided by 24. If you input this into your calculator, you get the answer is 38.4 degrees, which is A here. So, today, in conclusion, we have learned about the trigonometry ratios, sin, cos, and tan for finding lengths, then arc sin, arc cos, and arc tan for finding angles. But so far, these are all only for the right angle triangle. What if the triangle is not a right angle triangle? What if, for example, we have this triangle, this one is 80 degrees, this one is 70, then this one is 30. You cannot use the hypotenuse formula here or the regular SOHCAHTOA here. You probably will need to find the lengths of it by using the cos rule, or maybe find the area by using the sine rule. But I think that's all for now. Maybe I can teach you guys about the sin rule, the cos rule next time. That's all for today. Thank you guys for listening. Bye bye.